Welcome, Hornets. In today's video, what we're going to be taking a look at is how do we find a specific value of a that's going to make a function continuous? One of the things that we have to be aware of is being able to distinguish not only whether a function is continuous or not, but what makes it continuous. So I've got a couple of examples here that we're going to go through that I hope will help you with your homework and also in our future quizzes. Notice in our first problem here, we're trying to find the value of a that makes the function g of x continuous. Now, in order to do that, what we're going to do is we're going to be asking ourselves, what is required? Well, the first thing that's required in order to have a function that's continuous is to have the limit that exists. That means that the limit as x approaches 0 from the left for this g of x must equal the limit as x approaches 0 from the right for this same function. Yet we know what this limit is. The limit as x approaches 0 from the left for 4 sine x divided by x has to then be equal to the limit as x approaches 0 from the right for a minus 2x. Well, we know that this limit, when we evaluate it, since it's our special limit, sine of x over x for the limit as x approaches 0, we know is 1. It has to be 4 times 1, leaving me with 4. So I need to have 4 equal to, and now I'm going to plug in the 0 here, a minus 2 times 0. Notice that we end up with 4 equaling a. This is what we are looking for. The value of a that will make this function continuous. Same thing is going to happen here in the next one. In order to do this, we start with our first recognizable rule. The limit has to exist. Now, sometimes a graphic representation will help. For example, in this, we can draw a very reasonable graph of this. It's a line. And this line is y equals x plus a. We know that because when we factor out that numerator, x squared minus a squared, we get x plus a times x minus a, and the x minus a's cancel. That's from pre-calculus last year, finding the location of a hole. But they tell us that they want to fill in. Remember, if we have our point up here, it's not going to be continuous because it didn't fill in the hole. So we need to make sure that whatever we do, this point identified as A8 is filled in. Well, that means that the limit as x approaches the a value from the right and the left for x squared minus a squared over x minus a has to equal 8 because that's the value defined. Remember, the 3 criteria are that the limit exists. Well, the limit does exist, it has to. But the value has to be defined at that limit. So here we have our limit. This is the value we have to define it as. And when we go through this, we end up with 2a equals 8. And therefore, a must equal 4. Now, some of you are going to say, well, wait a minute, how did you get 2a? Well, I evaluated this right here. I took a look at it and said, well, I'm looking at x minus a, x plus a, over x minus a, which cancel, allowing me to find my limit as x approaches a by plugging it in and getting 2a. I then put it in, I solved, and I found that my value was a. Well, that's our goal. Now, this can happen with almost any function that we encounter. Let's take a look at another one that looks a little bit more complicated, but really isn't. Again, it looks complicated, but it isn't. All we're going to do is set up our limit statement. The limit As x approaches 4 from the left, for this function, 2e to the ax minus 2 must equal the limit as x approaches 4 from the right for the natural log of x minus 2 plus x squared. Well, in order to find my limit, I plug in my value. So 2e to the 4a minus 2 has to equal the same thing. Now, let's just make sure I have my 3 in written correctly. I plug in the 4 and I get the natural log of 1. I'm just going to go ahead and put the natural log of 1 in. So having the natural log of 1 and then adding 4 squared, which is 16. But we know the natural log of 1 is 0, so we go ahead and we rewrite it as 2e to the 4a minus 2 equals 16. If we add 2 and then divide, we get our e to the 4a will equal 9. Well, I'm now going to exponentiate. So we're going to solve. This is now back to pre-calculus and a little bit of algebra 2. We exponentiate both sides. The natural log of e to the 4a must equal the natural log of 3 squared. And you notice I prefer to have that 3 squared instead of 9. Continuing, the 4a drops down. E to the natural log of e is 1. Power moves in front, and I'm now ready to divide by the 4. When I divide by the 4, I find a is 1/2 the natural log of 3, or the natural log of the square root of 3. This is the answer we're looking for. Notice, finding a value a is not difficult if you understand what's happening. It requires you to work with the condition that the limit from the left has to equal the limit from the right, and the value has to be defined at that limit. As long as you keep those three clearly in mind, obviously that implication is that the value of a exists, you should be okay. Thank you very much, Hornets. Please let me know if you're having any difficulties. You should come into my office hours if necessary. Thank you very much. Be well and be safe. Thank you.